Okay, welcome to the class Modern Manufacturing Process. Today it's going to be lecture 8, rubber processing and shaping. Rubber processing basically similar to the plastic processing. That means after the production of raw rubber and after the production of raw plastic, it's kind of similar. Uh, the, to manufacture a certain part from rubber or plastics, they are more or less similar. And but the industry is kind of different based on the applications, because the rubbers are applied mostly in the case of tires. Actually, most of the rubbers are consumed to manufacture tire, and there are some other applications. You already know about a lot of applications of rubber. And if we talk about the percentage of rubber that is used in various industries, it would be like tires would be like 70 to 80% of the rubber being used in the tire industry. And as you know, tire actually need to be changed frequently, so there are a lot of consumption of tires, and also rubbers are used for to manufacture these tires. And the production process, basically you can categorize it into two groups, like how to manufacture the raw rubber or manufacturing process of rubber from natural agricultural source, and finally the processing into finished good. And this is the part, like second part, the compounding, mixing, shaping, vulcanizing. This actually kind of similar to the thermoplastic or thermosetting materials. It's kind of similar, but the production of rubber it's a bit different. Either synthetic or natural rubber. Natural rubber is basically comes from the tree, from a rubber tree, and the synthetic rubbers come from petroleum. In the petroleum industry, they can produce synthetic rubbers. And we will basically talk about the natural rubber manufacturing process, and then we'll talk about the processing into finished good, how to process the rubbers to manufacture various parts. And also we'll see how the tires are manufactured using rubbers. And to talk about the rubber industry, natural rubber is basically, it comes from from a plant, and then that is developed into the raw rubber by some processes that we'll talk about. And this is basically the agricultural industry. The rubber manufacturing of natural rubber is involved with the manufacturing industry, agricultural industry. And for synthetic rubbers, it is petrochemical industry are involved in manufacturing the synthetic rubbers. And finally, the processing or shaping into various parts is actually called the rubber industry. Just to classify the industries, like which industry actually deals with what part of the manufacturing from the source to the final product. The production of natural rubber involves the rubber extract from the tree, which is called Hevea brasiliensis. These are the kind of hard names to spell or pronounce. This is called latex, basically, mostly available in the Southeast Asia, and there are some available in other parts of the world too. And the latex is basically a dispersion of solid particles. Solid particles are their hydrophobic part and hydrophilic part. Hydrophilic parts of the solid particle actually stays keeps the water trapped into them, and then hydrophobic part actually creates the bonding. And the polymer particle that is used in here in the case of latex is like polyisoprene in water, and that polyisoprene actually constitutes the chemical constitution of the rubber is basically the polyisoprene, and which have a chemical formula C5H8. It is a monomer, and it can be polymerized to produce the rubber actually. C5H8 is the polymer, and there N actually indicates it's a polymer. When the monomers are connected together to create a long chain, then we call them polymer. It's chemical stuff. And in the chemical substance that the polyisoprene actually stays in the rubber as an emulsion, and which the polyisoprene actually constitute only 30% of the rubber in the emulsion. And how to manufacture the rubber from latex? The latex that is found from the tree, the extract from the tree that is converted into rubber. And to facilitate that we actually use some kind of chemicals like formic acid or stearic acid. Those can be used to coagulate the rubber. That means to concentrate the rubber. The liquid extract from the tree has to be concentrated using stearic acid or formic acid, and it takes like 12 hours when you put stearic acid on the tree extract, the liquid extracted from the tree. Then it takes like 12 hours for coagulation. It becomes like a thick paste like structure, and then that coagulum, now it's kind of soft solid slab. It's not completely solid, it's kind of a Newtonian fluid, and then that is actually squeezed between the two rolls. It's kind of the rolling process is used to squeeze out the extra water from the rubber. The latex actually contains a lot of water. That water can be removed by squeezing through the roller, and it is squeezed until the thickness almost becomes like 3 millimeter for each rubber sheet. That can be called the rubber sheet that is formed after the rolling. And the sheet are then dropped over wooden frames. That means it is placed in the wooden frame and then dried in smoke houses. And the smoke house is like the house where you put the hot smoke into the room and then keep it there for several days. And sometimes there are more advanced techniques are also available, like hot air can be used to cure the rubber instead of using a smoke house. Smoke house concept is basically a traditional concept. And nowadays, the hot air is basically used for curing the rubber for like 2 to 3 days. And those sheets that results from the smoke house is called a smoked sheet. And in some cases, when it is air dried, then it can be called like air dried sheet. Okay, and this is considered a better grade rubber. When you use the air dried sheet, then it becomes much more clean and inclusion free product, and that is why it is called, it's kind of better grade. And more better grade can also be produced by two coagulation process using warm air drying. Okay, first you do the warm air drying, and then you do the final curing at hot air. Okay, and then more better grade can be obtained. It actually increases the cost of rubber, and depends on the application where you are using these rubbers. Okay. And in the case of synthetic rubber is kind of polymerization reaction that is kind of that occurs in the petroleum industries. They use the polymerization to produce actually that C5H8 that we have seen to manufacture the synthetic rubber. Unlike thermoplastic and thermosetting polymers, which are normally supplied in the to the fabricator as pellets, most of the plastic materials are basically used either in the liquid state or in the pelletized form. That means the particulate form. They are supplied to the fabricator. Actually, fabricator indicates that the industries that actually uses those to manufacture usable products. And the raw material for those factories will be like the pellets or particles or liquid resins. Okay, and the synthetic rubber is kind of different. It is supplied to them actually in the form of sheets, large bales. Okay, and that is the only difference between the polymers, plastics, and rubber. And it is a long history, that means the tradition to handle natural rubber in this unit loads. Okay, using the bales. A certain amount of weight is the determining parameter for price or quantity sometimes. So this is so far we have actually we are not going deep into the synthetic rubber manufacturing. It involves the chemistry, just the chemistry to form from the petroleum to the long chain rubber polymers. So we're not going into that, but in the case of natural rubber, the whole process, if I want to summarize, is that first you take the liquid extract from rubber tree, and then that liquid extract is mixed with the stearic acid and for like 12 hours. And then when the coagulation occurs, that means the rubber particles come together and they form chains. That means they polymerize, and then that mixture is passed through the rollers to remove the excess water from the rubber, and then it is dried into inside the either smokehouse or air dried, or two-step warm air drying and the hot air drying process, and then you get the rubber sheets, and that sheets are actually the final product in the case of natural agricultural industry, and that sheets are further processed to manufacture usable parts by rubber industries. Okay, do you have any question so far? All right, now we are actually moving to the final product manufacturing, like for example compounding. Rubber, before compounding, actually rubber, there are some additives that are used to increase the properties, enhance the properties of rubber. Compounding is used to make mix the additives with the rubber basically. And compounding adds chemicals for vulcanization such as sulfur. Sulfur is also added to rubber for vulcanization. That means vulcanization means the production of long chain. The short chains are produced in the manufacturing of rubbers that is very soft. And when you use the vulcanizing chemical like sulfur into the system and then heat it up at certain temperature, then you'll get the small chains will be connected together, and then I'll show you the vulcanization process actually, how the vulcanization works. And the additives that are used to enhance the properties, basically the mechanical properties, those act as the reinforcing filler into the material, and those involves like that actually enhances a few properties like tensile strength, hardness of the rubber. Okay. There are some reinforcing fillers and some non-reinforcing fillers. It involves like to impart certain properties for certain application in terms of cost, and also it is the compounding that the specific rubber is designed to satisfy a given application in terms of properties, cost, and processability. Depending on the processability or how much the end users requirement, the properties can be modified by applying the reinforcing fillers or non-reinforcing fillers like colors. Okay, color can be a non-reinforcing filler, and reinforcing filler would be like if you look at the rubbers that has a small reinforcement like various kind of natural fibers or sometimes the synthetic fibers like nylon are used to enhance the mechanical property of the rubber. And that's what the purpose of compounding, to add additives to the rubber to enhance the mechanical or physical or processability of the rubber. Carbon black is one of the reinforcing material for to enhance the properties of the rubber. This is the most widely used filler for rubber, because the rubber is basically used in the tire industry and tire is black, and carbon black is used to enhance properties like tensile strength and resistance to abrasion, which is very important in the case of if we talk about tires, which is continuously experiencing friction. If we can increase the decrease the rate of abrasion, then it will be much better, and that is why carbon is used, which actually gives the rubber a very high resistance to abrasion and also gives the tensile strength. And it also, carbon black also provides protection from ultraviolet radiation, and most rubber parts are black in color because they are of their carbon black content. Okay. And other fillers involve like china clay. Instead of, sometimes if color is the problem, like you don't want the rubber to be the black color, then in the case you can use the like china clay, which is hydrous aluminum silicate, which can also uh, give the similar property like carbon black, but not 100% like 100%. And other polymers can also be used to as fillers, such as styrene, PVC, or phenolics, that can also be incorporated with the rubber to impart some to modify the properties of rubber. And sometimes recycled rubber is also used to in the rubber products to consume the recycled products to facilitate the recycling. And antioxidant. These antioxidants are also important to be used as additive in the rubber, because it provides like fatigue and ozone protective chemicals. If you are using a rubber and it is like getting a rubber band and it is getting like within 2 to 3 days, it is not the rubber property is degrading, then it will be very difficult. And that is why these antioxidants actually perform is required in rubber to enhance its fatigue property and also the ozone protective chemical protection against ozone. And like sometimes you need to add color and plasticizer for softening oils, blowing agent to produce the foamed rubber. If you want to manufacture the foamed rubber which have cellular structure inside, then the blowing agents are used, like hydrogen peroxide, which actually used as a blowing agent that actually act as that gets trapped into the rubber to manufacture the create the foam. And the mold release compound are also used to facilitate the release of final product from the mold. If you, for example, if you are using compression molding to manufacture a product and that product has to be removed from the mold, then mold release compounds that are used with the rubber act as a that comes into account, and the releasing becomes much easier. The mixing, how do you mix those additives into the rubber? The additives must be thoroughly mixed with base rubber to achieve uniform dispersion of ingredients. The base rubber has to be properly, the additives has to be properly mixed with base rubber. Otherwise, if there is no uniformity, then the material property will also not be uniform. And basically, the uncured rubbers have high viscosity, so the mechanical working of rubber can increase its temperature up to 150 degrees Celsius. That because the rubber product that is available as a sheet, that is very highly viscous. And if you want to mix something with that rubber product, then there is friction involved, and that because of that friction between rubber and the mixing devices, the temperature can increase like 150 degrees Celsius. And if the vulcanizing agents are present from the start of the mixing, premature vulcanization would result, and this is called rubber processor's nightmare. Okay, because the vulcanizing has to be done at the last state of manufacturing rubber product. And if the temperature increases like 150 degrees Celsius and you have mixed the vulcanizing agent with the rubber before mixing, then there will be partial vulcanizing, and that means partial chain formation, and that will actually interrupt the actual vulcanizing process, and you will not obtain your desired property. That is why you need to really take care of the temperature when you are mixing rubber with mixing additives with the rubber. That mechanical mixing process has to be you have to be really careful so that no vulcanization occurs during the mixing. And there can be a different type of mixture, like there are basic types, two roll mill or Bunbury type internal mixer can also be used for rubber processing. And in the case of two stress, the mixing actually consists of two stress to avoid the temperature premature vulcanization. At the first stage, carbon black and other non-vulcanizing additives are combined with the raw rubber. And in the second stage, first stage, it is called the master batch. And then in the second stage, the mixing is complete, then cooling time has been allowed. It's just two mixing is carried out in which vulcanizing agents are added. At first, the first stage, the additives are added, and then in the second stage, the vulcanizing agents are added into the rubber, and then the second stage mixing is carried out to conduct the vulcanization. Okay, and how to reinforce the rubbers using filaments. And most of the rubber products are they use, like in the tires. If you want to cut the tire, you will see that there will be some fibers available in the tire, or in the conveyor belts, or any other belts. There are fibers available inside the rubber actually, and those are actually the manufacturing of fiber reinforced composite. It's kind of similar to that. Those fibers are added. There are various processes. I'll show a few of them. And fiberglass steels are used as the reinforcement. Sometimes steel belted radial tires can uses the fiberglass and steel reinforced rubber. And these continuous fiber materials must be added during shaping. When you give the shape of rubber to a certain shape, then you use this kind of fiber material. It's kind of composite manufacturing actually, using the by reinforcing with fibers of either steel or nylon, synthetic fibers like polyester, and or the natural fibers, whichever your requirement is. It depends on your requirement. And the shaping and related processes for our products include like extrusion, calendering, coating, molding, and casting. Four basic categories of shaping processes are available in there. Like for example, extrusion is kind of similar to the plastic extrusion. Calendering, we have also studied that. Coating is also similar to the plastic, thermoplastic or thermosetting plastic manufacturing. Molding and casting, it's also similar to that. And some products require several basic processes plus assembly works. For example, if you want to manufacture tire, there are several processes involved to manufacture a tire. We'll look at into that. Extrusion, basically, it's similar to the plastic product, but in this case, the length to diameter ratio of the extruder barrel is less than for thermoplastic. Thermoplastic, typical range for rubber extrusion is 10 to 15, because if this ratio is higher, then it will be very difficult to extrude the rubbers, because rubber has higher viscosity compared to the plastic materials. That is why the typical range is like 10 to 15. The length of the screw to diameter of the screw has to be like within 10 to 15 to handle rubber. Otherwise, there will be like premature cross-line linking, which is called the premature vulcanization that will occur. And there is also another important thing is that, like similar to the plastics, the die swelling occurs when the rubber products come out of the extrusion die. It expands. Okay, and that expansion has to be taken care of. Like when you design the die, then you have to consider that expansion, how much expansion occurs after getting out of the die. And highly plastic polymer exhibits memory. Memory means it goes back to the initial position. Even you give it a shape and then it comes back to the initial position. That is called the shape memory. And the rubber has not yet been, after extrusion, vulcanization has to be done. Before extrusion, you cannot vulcanize it. Otherwise, it will you will not be able to form the product. Okay. And the calendering, I don't know why. Okay, just to go back in here to explain the mixtures of rubber processing. There are two types: two-roll mill. These are the two-roll mill. The rubbers are placed in here, and then additives are also added in this region. Additives are added in this region, and then the both rollers rotates, and then mixing occurs in this in here. Okay. And in the Bunbury type internal mixture, it is like a hopper is used to produce the rubber, and there are the rotors that actually uses the rotation of this rotor actually performs the mixing, and there is a very high temperature temperature is very high in this case, and that is why there is cooling channels are also provided to facilitate the cooling during mixing. Otherwise, there will be premature vulcanization. And let's go back to the okay. This is the calendering. Calendering, actually, rubber strokes is passed through a series of gaps, like decreasing gaps. This gap is wider, and then there is a smaller gap. There is a smaller gap. There is this gap is much more smaller. Okay, that's how we do the calendering. Okay, the rubber sheet thickness is slightly greater than. Just give me a second. All right, for let's go to the calendering. Can you see the slide?
Yes, sir.
Okay. So this is how the calendering occurs actually for a series of gaps of decreasing size by a strand of rotating rolls. That's how you produce actually to manufacture the sheets, rubber sheets. You can use the calendering method to manufacture the sheet, and you have to really consider like the swelling of the rubber when it comes out of the final shape. So the rubber sheet thickness is slightly greater than final roll gap due to the die swell. That means once it comes out, the final thickness will be larger than the gap between these two rollers. Okay, that's how we need to design like what would be the output size of the rubber. And there is roller die process. In this case, extrusion and calendering both occur simultaneously. When the extrusion comes out of the screw, it also passes through the calendering rollers to give it the final shape. Okay, and this is the combination, and it gives the better dimensional control, and better quality product can also be obtained by this method. It's called roller die process. And there is the coating. The coating is basically the composite manufacturing. That means reinforcement can be done using these methods. Like sometimes you can use the rubber coating on the fabrics of various kind of synthetic or natural fabrics. You add the feed stock in here, you put the rubbers in here, and then fabrics from another roll, and they combined compressed between two rollers, and they stick together, and that's how you get the coated fabric. Or if you want to produce the fiber reinforced composite, that can also be done using this coating method. And there is molded rubber product. That means to manufacture gasket, seal, suction cups, bottle stops, okay, and many other foamed rubber products are produced using molding. That means you have a mold, and then you put the rubber into the mold, and then you use the vulcanization, or you do the curing. Okay, after curing, you'll get the final product. It's kind of compression molding. Okay, and the molding is an important process in tire production too. In the case of tire production, you need to produce some materials initially, and then finally okay, the molded, that's how it produce the molded parts. And foamed rubber can also be produced using the molding. Like you will have a cavity, and then inside the cavity you put the rubber raw material, and then using the blowing agent will be present in that cavity too. And once the vulcanization is done, then when you take it out, then you will get a foamed rubber part. That means the blowing agent will actually produce the gaps between the rubber material, and you'll get a formed rubber product. And in the case of tire production, you also need this kind of molding, because you need to produce various rubber parts separately, and then you have to combine them together. And molding can be like compression, transfer, or injection molding, similar to the plastic molding processes. So we're not going into detail of that. And curing, that means curing of rubber means the vulcanizing. In the case of thermosetting plastics, curing occurs at a different temperature. And also in the case of rubber processing, the curing occurs, that means the vulcanizing occurs at a certain temperature. We need to increase the temperature, but it is usually a very low temperature. The vulcanizing process occurs. That means the major polymerization of rubber occurs. To know a little bit about vulcanization, the treatment that accomplishes cross-linking of elastomer molecules. Basically, you have like I'll show you image. Initially, the long rubber chains are like this. They're very long rubber chains. These are the raw rubbers. This is also a chain, but these chains are not connected to each other yet. Before vulcanizing, it looks like this, and after vulcanizing, if you want to produce the soft rubber, then the cross-linking has to be limited. There will be very small amount of cross-linking between the polymers. And then if you provide more cross-linking, that is more time for vulcanization, then it will be like more chains will be connected more, and then this will be like hard rubber will be produced in this case. Like hard rubber, one of the example of the hard rubber could be like the tires, and the soft rubber would be like the hair bands or balloons. Sometimes can also be used as rubbers. And to do the vulcanization, we actually sulfur is used traditionally, and it would take like 5 hours for vulcanization at a temperature 140 degrees Celsius. Sulfur is mixed with the material, and then you do the apply the certain temperature like 140 degrees Celsius temperature. You keep it for 5 hours, and then you'll get the finally cured rubber product. And it's not necessarily the sulfur is nowadays it's not being used because it takes really long time for curing. Like 5 hours is very long time for curing one single part, and that is why different methods have been developed by the researchers. And the various other chemicals that are used for to enhance the time for curing or time for vulcanization involves zinc oxide stearic acid are used with the sulfur. Sulfur is also used, but in the case zinc oxide and stearic acid, they actually used increases the it decreases the time of vulcanization, a kind of catalyst used, and it takes like 15 to 20 minutes to cure a part. And other rubber products are all involved. We have already talked about all of these. Actually, the 75% is like for used in tire manufacturing. So we'll have to look at the tire manufacturing. And to construct the tires, actually it involves a tire assembly is many components. There are some many components are used to manufacture the car tires or any other tires. Nowadays it has also like there is tubeless tires are being used, so there more care has been taken has been given to manufacture the tire so that you can use the tubeless tires can be used. The internal structure of tire known as the carcass. Carcass consists of multiple layers of rubber coated cords. There will be multiple layers of rubbers, and those are called plies. They put together you put together all the plies, and then you apply the vulcanization or curing. Then you get the final tire. And for manufacturing these plies, some cords are used. So those cords are basically the nylon, polyester, fiberglass, or steel. These are the reinforcing long fiber reinforcement of the tire, which provides inextensibility inextensibility to reinforce the rubber in the carcass. Okay, it's kind of enhancement of the property. If you look at the internal structure of a rubber or of a tire, it involves like bead coils. These are the initial part. Actually, this act as a this interrupts into the rim of the vehicle. and then there will be inner linings and also the filler between inner linings. Between the inner linings there will be filler to put get the gap, and the plies. These are the plies actually reinforced with various kind of fibers, okay, to enhance the property of either the various strength of the material of the tire is increased because of this cross plies. Sometimes they are used like in various different orientation. The orientation can be like 45-degree, or there are many other different degrees can be used depending on the application. And finally there is the tire tread, which is called the sidewall. Sidewall is manufactured. Sometimes these treads are provided into the die where you manufacture the tire, and sometimes you can cut separately. Separately, these treads are cut after manufacturing the complete tire. And the ply orientation can be different, like this one. It has different ply orientation. This one has another ply orientation. That means the fiber orientation basically in the rubber sheets. The sheets are produced separately, and then they are stacked one after another, and then the curing is occurred. Okay. The three steps of of tire manufacturing is like preforming of components. That means that you have to manufacture all these components, inner lining, radial plies, or belts, or treads, or filler, or everything you have to manufacture separately, and then building the carcass into a forming element, forming device, where you add different components together, and then you finally do the curing. You put it into a mold, and then you do the curing. Variation exists, depends on the vehicle types, or this manufacturing process can be different based on the different requirement of the of various companies. The preforming actually involves like manufacturing fiber reinforced composite. Actually, I'll show you this. The preforming basically different layers of the rubbers of the tire is manufactured separately. That is actually the summarizing. If you summarize this, different parts are manufactured and cut into size, whatever the size you need for to manufacture the tire. You cut them up into required size, and then you stack them up in a support drum. In this support drum, you actually organize all the plies that you want to apply. This is the bead coil, and then on top of the bead coil, you apply other strips, like other fiber reinforced rubbers are placed in place like this into a cylinder. And after completion of these of stacking of various layers, you actually put it in a expandable diaphragm. All the setup is placed in expandable diaphragm. This expandable diaphragm is placed into a mold. Okay, this is a split mold. Uh, Once you put this system into this mold and close the dies of the mold and apply air pressure, then the actual the outer side of what we call it, like the arrangement, outer shape of the arrangement actually takes the shape of the die that you are using because of the pressure. And under pressure you do the curing. You heat it up 140 degrees Celsius temperature, and then you keep it for some time, and then you will get the final shape of the tire. And that is how you do the tire. And treads are sometimes integrated part of the tire, and sometimes the treads are cut separately, especially for large scale tires like earth movers. Those tires are the treads are cut separately sometimes. Sometimes it can be molded in this place. Okay, any question till now? Actually, it's been a very long lecture. Do you have any question? All right. There are some other rubber products. One of them is rubber belts. This is widely used. I think this is the second most usable product of rubber. Uh, and conveyor and pulley systems are basically use this kind of rubber belts. This rubber is ideal for these products because of its flexibility, but the belt must have little or no extensibility. If the belt extends a lot, then it will loosen up, and that will not actually give you the proper service. So hard rubbers are used for manufacturing belt. So extensibility will be less. And that is why the more reinforcement is given in the case of belt using fibers. And there are hose. Hose is another application for rubber. It can be like plain hose. There is no reinforcement. It is just extruded tubing, rubber tubes, and sometimes the reinforced tubes are also used. There will be multiple layers can be used for reinforced tubes. The inner tube reinforced layer to increase the mechanical property, and then the outer layer to protect from the environment, from the environment applied by extrusion, and there will be outer layer. It depends on the application actually, like which orientation you're going to use, whether you're going to use only inner tube, or you're going to use only reinforced layer, or you are going to apply the outer layer too. It depends on the application of the hose. In the footwear industry, rubber is used for soles, heels, rubber overshoes. Certain upper parts are also made of rubber, and most of these parts are made using injection molding or compression molding, and certain special technique can also be used in the shoe industries to depending on the requirement of the customer. And the rubbers include both solid and foamed material. So sometimes foamed rubbers are used for like for the comfort of human comfort in the shoe, in the inside the shoes. They provide this kind of foamed rubber. For low volume production, sometimes rubber sheets are cut into, or rubber flood stocks are cut into different shapes to manufacture the product. Okay, like. And to design the product based on the rubber, it is in the case of economic production quantities, the rubber parts produced by compression molding can often be produced in quantities like 1,000 or less. In the case of compression molding, it is not that expensive, but in the case of when you the mold cost is relatively low compared to the other molding method. But in the case of injection molding, the rubber parts require high production quantities because of the expensive molds. The molds used for injection molding are expensive, and also the injection molding machine is also expensive, and that is why the mass production is required to justify the cost of manufacturing rubber products. Okay, that's all for rubber processing and shaping. This is a bit long lecture. However, I have moved very fast actually, and did not give you much time for question and answer. If you have any question, please ask. I will move to that slide and then clarify.